Okay, if you're watching this, that means in theory you've gone through all the content for the integration chapter. Hopefully you reviewed some of it, perhaps some bits you're still patchy on. The idea is now to just sort of go through a bit of mixed practice. I've got sort of 6 or 7 questions that should take you, hopefully just under an hour in theory, if we're going by 5 marks for 6 minutes. So let's take a look at these. They're sort of taken from various parts of integration practice. So you might be doing some integration by parts, differential equations, integration by substitution, hopefully a mixture. So let's take a look at the first question. This one's just a nice basic integration differentiation question. Not too much problem solving involved. Give it a go. Okay, and then the answers are here. Okay, and for this one, if you want to just try it without a hint, you can pause the video now. And if you do want a hint, if you were struggling with this integration, you need to be using integration by parts. Once you've done that, you're going to be using your result from this to help you answer this part of the question. And the way that's going to happen is when you separate the variables, you'll end up with something that looks like x e to the minus x. So you'll use your result from A to then help you with part B. Okay, and let's look at the actual answer. This one's a variation on the previous question, so if you're able to do that one successfully, then this one's just a little bit of extra practice. Pause the video now. And your answers are there. Okay, another little bit of just basic integration. Finding areas under a curve, nothing too tricky, hopefully. See how you get on. Pause the video now. Okay, and then your answers are here. Okay, 2 questions and a challenge left. Hopefully you're still getting on. For this one, it looks quite simple, but the reason I've included this as one for you to do is because it's just so incredibly common. It's so incredibly common that you need to do something like this because it's effectively almost in your formula book, the answer to this one. But the result that you end up getting for this integral is such a key result, and really you should know how to get it yourself. So have a go at that. I won't tell you what the substitution is. I'll let you have a go first, but if you do want to know, then I'll give you a hint in just a moment. But if you don't want the hint, pause the video now. So if you want the hint, try this substitution. X equals tan u. Pause the video now if you haven't already tried. Okay, and then the answers. There it is. It's just arctan x. And that comes as a direct result of the fact we used x equals tan u as a substitution. Okay, final big question now to try before the challenge. The challenged question, to be honest, is quite a fun, cute little question, whereas this question is more just something that's a little bit difficult. So it's a nice one to try to really test you've understood modelling and differential equations related to modelling. So give that one a go. Pause the video now. Okay, and then the answer is there. Cool, and then if you've made it this far, just for a bit of fun, I quite like this question. It's a nice little challenge. I've left the hint in because if you're not doing that, then you're just certainly going to go in the wrong direction. Draw a picture of what mod of f of x looks like, where f of x is x squared minus x minus 2. Once you've done that, really think about then what is the integral of that function, what is the area under the curve, and see how well you do with that. You can pause the video now. Okay, and there's your answer.